Hello and welcome to Oracle State Park, a 4,000-acre wildlife refuge with over 15 miles of trail for hikers, mountain bikers, and equestrians. The park is also home to the historic Canali Ranch House. Built in 1929, this 4-level Mediterranean revival-style design has scenic patio views and a fascinating story of an early cattle ranching family of siblings who ultimately donated their land to be a wildlife refuge in perpetuity. Oracle State Park has a long tradition as a center for environmental education, offering school programs on the trail to share the ecology and cultural heritage of this oak grassland community. The park's environmental education mission now adds dark skies, appreciating dark skies as a limited resource worth protecting. So welcome to our virtual Star Party and Dark Sky celebration. We look forward to a return to on-site programming at Oracle State Park. So many of our past Star Parties have featured live music, guest speakers, and telescopes to share. For this virtual event, we'd like to offer you some familiar elements, so we're going to start with some live music. We hope you enjoy local musician Dave Taminga on guitar to get us started.
Circled in the eye of some devil in the cold light of an evening moon. I would not believe that I could pull away, and the trees seemed to summon an icy wind that held me frozen in my shoes.
Call out the thunder, let it rain on me. I've been one time too many and I won't be left broken this time.
Don't it make you wonder when you find yourself lost inside an empty space? How could you have grown so far away?
In the midst of desperation you open your eyes and see the dawn has come again, giving life to the love you have bounded, giving voice to the life you have found, set it free. We're all in this together and the world could be better for trying.
When the sun rests soft on your shoulder and there's comfort in the breeze, could you believe that you're the only one
Who has seen what we have done, and instead of trying to run, he'll breathe a sigh into the trees. Despite all the deceivers that'll throw him down, he believes in the love that can be found in the lives of all men. Set it free. We're all in this together and the world could be better for trying.
Hi, I'm Mike Weasner. I'm a volunteer here at Oracle State Park. I'd also like to welcome you to the park for its very first virtual Star Party in celebration of International Dark Sky Week 2021. 7 years ago on this date, the Oracle Dark Skies Committee held its first meeting to start preparing an application to the International Dark Sky Association. A little later in 2014, the park was honored as the first park in the Arizona State Park System to receive the designation as an International Dark Sky Park. I'd now like to welcome Dr. John Barentine from the International Dark Sky Association. He's a noted author and astronomer and dedicated to doing public outreach on science and protecting of the night sky. Over to you, John.
Good evening and welcome to the first ever Oracle State Park Virtual Star Party. My name is John Barentine, and I'm the Director of Public Policy at the International Dark Sky Association headquarters here in Tucson. Over the next 30 minutes or so, I will be sharing with you a little bit of the background of dark skies in the region, what we're doing as an organization to try to protect them, and some of the challenges that we think we're going to face in the next decade. So here's an overview of the journey that we're going to take together during my presentation, starting with the biggest of big pictures. I'll talk about how the world is changing due to light pollution in different parts of the world. Second, I'll go into a little of what I call night history about Southern Arizona, the history of astronomy here and the importance of it in our culture and even our local economy. And then from there, I'll move into the work that IDA does to try to preserve dark skies for the benefit of astronomy and for other purposes, both here and around the world. Get into some of our activities specifically here in Southern Arizona, and then wrap with some speculations on the sort of challenges that we're going to face in this work in the coming decade. So first, let's start with the biggest of big pictures, and that is a view of the entire world as if it were night simultaneously everywhere at once. This is a composite satellite view made up of many thousands of individual images taken by NASA satellites over the course of a year in order to ensure that every point on Earth was observed at least once when there were no clouds in the way. So this view of the Earth is artificial. It's as if there's no weather, first of all. It's as if it were night everywhere on Earth at once. And what we see is a world that shines brightly. There is a lot of human-caused light, as you can see, outlining many of the continents. The continents themselves, the land masses stand out from the oceans is a little bit brighter because of moonlight during the same period when the Earth was observed for the purposes of making this map. And you'll notice that the light tends to concentrate in certain parts of the world, North America, Europe, India, Japan, elsewhere. And at first you might think that this is a map of where the people live. And at some level that's true, although there are plenty of people, for example, in sub-Saharan Africa, upward of 1 billion of them, and yet there's not nearly as much light in that part of the world as others. So in addition to showing us where people live, it also says something about their level of economic development, and in particular in developing economies like Africa, the extent to which they have already electrified and brought light into their cities. And it turns out that Africa is one of the places where these indications of light at night are growing the fastest right now. So just keep in mind that the problem that I'm going to be discussing isn't unique to the United States or to Arizona in particular, but it really is an issue that affects most of the world at this point. And that problem is light pollution, which does not itself have a universal term that everybody agrees on. But the version that I put up here is the one that I like in particular because I think it really gives a flavor of what we're trying to get at. And that is light pollution is any adverse effect or impact attributable to the use of artificial light at night. And that problem is kind of suggested by what you see in this image here. Lights on the ground, there's some fog in the air that's kind of scattering and reflecting that light back down to the ground. There's a lot of indication of human activity in this picture. And at night, one of the most visible ways we see that is this effect that we call light pollution. So what is light pollution beyond that very general definition? Well, it's all of the examples that I've shown here. These are all symptoms of light pollution in one way or another. And you'll notice that they're really focused on what's happening here on the ground. It's not just a matter of whether we can see the stars. It has these effects on people beyond access to the night sky. And it's as everything is familiar as the picture in the upper left that we call light trespass, where light that's emitted on one property is received on another, to the example of glare down in the lower right. Imagine driving at night in a dark place and someone comes around a corner and they have their high beam headlights on, and for a moment you can't see anything because you're staring directly into that light. That also is an example of light pollution. So when we talk about confronting or solving this problem, in addition to trying to preserve the nighttime environment and keep night skies dark, we're also trying to deal with all of these other effects that we see from all of this use of outdoor light on the ground. So fundamentally, what causes light pollution? The answer to that question is something that we refer to as artificial light at night, or by its acronym, ALAN. So if you hear me use that term, what I'm referring to is this artificial light at night. And the pictures on the right suggest that there are kind of two environments in which we find this. One is at the top, which is really an outdoor context. So here's a picture of the skyline of Manhattan in New York City at night. Lots of indications of light of different colors, intensities. And this has consequences because of the use of all of this light beyond the benefits that it brings to humanity. There's also an indoor context to artificial light at night that's suggested by the lower image. And I'm not going to focus on that in this talk, but just beware that there are especially concerns relating to human health from all of this light exposure that we're getting inside our homes and offices and places like that at night. And that's a separate issue of concern, but it's sort of beyond the scope of this talk. So we're going to focus in particular on the kinds of places like you would imagine in that upper image. So what do we know about light pollution? After studying this for about the last 25 or 30 years, we've come to some pretty remarkable broad conclusions about light pollution. And that has to do with that first map that I showed you that indicates how pervasive that light is over how much of the Earth's surface we see those indications of light. And these are some facts from a paper that was published about 5 years ago based on a satellite remote sensing study that was done earlier in the decade. And already by that time, the majority of the world's population lived in light polluted areas. And I think the most startling conclusion is that third fact there: about 88% of Europe and half of the US by population experience perpetual twilight at night, which is to say that it never gets fully astronomically dark, no matter what time of night it is. And that's where these consequences or these externalities come about that we're so concerned about. Why is this happening? I think it comes down to these three basic ideas, and it has to do with the overuse of a certain resource, which is artificial light at night, an undervaluing of natural nighttime darkness, which itself is an important resource. And the thing that links them together is waste. It's a lack of mindfulness about the way that we use artificial light at night. And we think that if we approached it differently, that we could provide for all of our needs without wasting so much that ends up in scenes like this in a typical city, where you see indications of light from the buildings in the foreground all the way out to the horizon. And in short, it doesn't have to be like this, but we have to make the conscious decision to have a different outcome in order to avoid pictures like this. We think we can bring this back much closer to natural conditions without disadvantaging anybody who needs light at night for all kinds of outdoor activities that we might want to undertake. And I've alluded to this a little bit, but why this matters is much bigger than the issue of whether or not we can see the night sky. Light pollution touches on all of these broad subjects that I'm showing you here. I mentioned the wildlife a little bit. With the biology near the surface of our planet is really not adapted to all of this artificial light at night that we're putting out into the nighttime environment. And our wildlife are really suffering as a result of that. But there are other more sort of human focused concerns, like how will we sustain our climate and where will we get our energy in the future, to how does all of this light interact with crime and public safety, and making sure that our streets are lit adequately without overlighting them to the point that they create problems either for the people who use those streets or for the environment around it. So there's a lot of good reason to confront and solve this problem of light pollution, even if one's primary concern is not about the night sky necessarily. So next, I want to tell you a little bit about the night history of Southern Arizona and why this issue is so, relatively speaking, important here. And I'll start out by telling you that sky watching in Southern Arizona is truly ancient. There have been people in our region since at least about 12,000 years ago, and they've left behind in their material culture, there's some examples of which on the right, lots of elements of design motifs that suggest stars or sky watching through calendar keeping, knowing when the seasons are coming and going by the rising and setting of the sun, the moon, and the stars. There are a lot of indications that the people who have lived here from the beginning were very curious about the night sky, and at some level needed to know how it worked in order to survive in our desert environment. So the practice of watching the night sky here is something that goes back thousands of years into the past and is really ingrained in our culture as a result. As an example that's close to the city of Casa Grande, at the Casa Grande National Monument, there's a structure called the Great House. Some of you who are listening to this may have visited there before. It was built by a group of prehistoric peoples called the Hohokam in somewhere about the 14th century. And what we know about it now is suggested by the map or the plan of the building on the right is that this structure was built and oriented in such a way that openings into the building allowed for people inside to view certain astronomical phenomena through those openings, and that they were using this as a kind of calendar device. So you could say that the Casa Grande example here is a forerunner of the modern astronomical observatory. And the reason I bring this up is that there's really a continuum between that past history and our modern astronomy history in southern Arizona. And the landmark date for that was 1958 with the founding of Kitt Peak National Observatory just to the west of Tucson. It was meant as the nation's observatory where astronomers from any institution could apply for time on state-of-the-art telescopes and do very cutting-edge scientific research. And it's still the home to 24 optical telescopes and 2 radio telescopes, which makes it one of the strongest concentrations of astronomical telescopes anywhere in the world. By the 1990s, people had begun to call Tucson and the surroundings the astronomy capital of the world, given the number of professional astronomical observatories that have been built in this region. And Mount Graham up there on the upper right hosts the Large Binocular Telescope, which at the moment is still the world's largest telescope. It's right here in southern Arizona. And so in order to make these facilities as productive as possible, it's important to keep night skies dark. And this is not just for the benefit of the research alone. A study that was undertaken by the Eller College at the University of Arizona about the middle of the last decade showed that the economic impact of astronomy and space science in southern Arizona is tremendous. At that time, now this is an estimate that's 15 years old now, but at the time, the estimate was that the economic impact of astronomy and space science was worth about $250 million a year to our economy. And at that time, that was about as much as a Super Bowl host city could realize in terms of revenue from hosting that event. So as we like to say, and the number is probably bigger now, but that astronomy is a Super Bowl a year in terms of its impact to the economy in southern Arizona, which gives us good reason to want to keep the night skies here dark so that the investment in astronomy and space science will continue well into the future and continue to provide this important economic impact benefit to our community. But at the same time, the large cities of the West are beginning to crowd out dark night skies. This map provided by the U.S. National Park Service shows the light at night. You can see where Arizona is outlined in white here. As the colors get warmer, that means that there's more and more light in the night sky. And between Tucson and Phoenix and Las Vegas up there in the upper left corner, it's squeezing out the parts of the map here that are black or gray or purple, where the skies are naturally the darkest. And as these cities continue to grow, these darker regions in between them are rapidly shrinking. And that has implications for astronomy and much more. Next, I'd like to tell you a little bit about my organization and the work that we do. We are a movement 50 years in the making. One of the first mentions of light pollution in mass media was 50 years ago this summer in June of 1971 in a story in the New York Times that noted that the clear, dark skies of the Arizona night may be threatened by a new and insidious form of environmental contamination known as light pollution. And since that time, people have been concerned about the impact to astronomy from the light pollution, in particular, coming from Tucson. Our city enacted one of the world's first outdoor lighting ordinances in 1972 for the benefit of protecting the nearby observatories, and that work continues on to this day, certainly. Light pollution went mainstream in 1988 with the founding of our organization right here in Tucson. Our founders, there were 2 astronomers shown on the left, were concerned about the light pollution over the Tucson area as it was growing at the time and wanted to do something about it. But they already knew by more than 30 years ago that it was not just a problem of Tucson or of Arizona or of the United States, and that truly it was a global problem. And so they established our organization as an internationally focused environmental nonprofit organization in 1988, and we have been building up steadily ever since then. We remain headquartered here in Tucson. We have about 3,000 members and donors who support us. We have a number of volunteer chapters in countries all over the world, and we're affiliated with a number of organizations that have similar or related goals that we can work together on a number of projects. And this is just growing all the time. There's steadily rising interest in the issues of dark skies and light pollution throughout the world. And our philosophy as an organization is really summarized by one of our old logos that's there just to the right of center, which is this idea of stars up and lights down. The intent was to keep the light on the ground and not put it into the night sky. And we thought if we could convince enough people to do that, that they would find that they needed less light to do the job of illuminating what they wanted illuminated on the ground, and that we would avoid all that wasted light ending up where it didn't belong, whether that was beyond the area that needed to be lit, maybe in environmentally sensitive areas nearby, or in the night sky. So we're still a very grassroots level, volunteer, advocate driven organization that I think really is doing some good work throughout the world. Our mission is to preserve and protect the nighttime environment and our heritage of dark skies through environmentally responsible outdoor lighting. Notice that it's not about turning the world's lights off, because we don't think that that's a practical solution to the problem. We don't want to throw the world back to the Stone Age by taking away the use of electric light at night. Rather, again, we're trying to change the conversation, change the way that people think about their relationship to outdoor light at night. And as a consequence, that they'll find that they need less of it. And again, because we're really a grassroots focused organization, we take a page out of the environmental playbook of about the last 50 years, which really emphasized thinking globally about the problem, but acting locally to make the change. So our advocates are really focused on their local communities in terms of trying to make things different and hopefully better. And if we have enough interest rising up to the grassroots, we really think that we can make a global change as a result. These are some examples of the things that IDA does, both here in Arizona and throughout the world. We have engaged the lighting manufacturing community for many years to try to convince the manufacturers to make better lighting products. We certify lighting products, which may seem sort of paradoxical at first, that we would give our blessing, as it were, to lighting products. But these are products that meet a very stringent set of requirements that we create and publish on our website, so that it's very transparent. And the idea is to make products that are more friendly to the nighttime environment and result in less light pollution. And we've been very successful in that. There are many more products on the market now than there were when our program started many years ago. We work in the conservation space. We name what we call international dark sky places, of which Oracle State Park is one of our international dark sky parks, and so has been certified through that process. We do a lot of education and public outreach. We engage in some research ourselves to try to understand the problem better and what the solutions are and how effective they are. And we have many publications through our website, which I, of course, recommend anybody take a look at, which is www.darksky.org. And IDA provides practical solutions. This is our theory of change. This is how we think we're going to change the world. If we could get people to focus on these 6 very simple ideas, by keeping light restricted to the times and places it's necessary, trying to turn that light off when it's not needed, using adaptive controls so that we're only making use of the light when and where it's needed, keeping the color of the light warm. It turns out that that's very important for the protection of wildlife, and fundamentally keeping light on our own property so that we're not upsetting our neighbors. Just a sense of neighborliness, the same way that we would contain our other activities to our own property. If everybody thought about these ideas when they used light at night, I think we could solve this problem overnight. And the best part about it is, unlike other kinds of environmental pollution, where in some cases, once you stop the source of pollution, you have to wait years or decades to see a practical effect. This is a case where once we deal with the problem, the symptom, which is light pollution, just leaves the environment at the speed of light, so that we could see an immediate improvement from the moment that we decide to take on this problem and solve it. I think that's a very attractive aspect of the kind of work that we're trying to do. So next, I'm going to tell you a little bit about what IDA is doing, particularly here in Southern Arizona, and then I'll wrap with the challenges that we think we're going to face in about the next decade. I mentioned we have a conservation program called International Dark Sky Places, or IDSPs for short. This is a map of southern and southeast Arizona with an overlay, kind of like that National Park Service map I showed earlier, where the colors correspond to the amount of light as we're seeing from satellites orbiting the Earth. So we're going from cooler colors where it's naturally dark to progressively warmer colors as the light is getting brighter. And so, of course, there's Tucson. It stands out as a metro area of nearly 1 million people. You can kind of begin to see the edge of the Phoenix area up there at the top to the upper left. And each one of the yellow stars here is a certified international dark sky place. With the year that they came into our program, Oracle was first. And the silver stars show places where the certification effort is in process right now. And we hope that these will turn into designations in the future. So you notice that we're working in quite a few places in the region, and these encompass both protected areas like parks, as well as populated places like communities of Ajo, Tubac, Bisbee. All of these are part of our strategy. And in fact, what we're looking at in the future, hopefully, is a regional conservation plan, sort of like we have a regional water plan for ensuring that we have access to water 100 years into the future. Our idea is to have a regional lighting management plan so that we can continue to grow the population and the economy without creating too much of an impact on the night skies that are keeping astronomy and space science such a big part of that economy. So this is the main challenge that's in front of us. And we think that this conservation program can go a long way towards helping with that. We also support local communities in enacting and implementing outdoor lighting policies. Every one of the green check marks on this map is a Southern Arizona community that has an outdoor lighting municipal ordinance on the books and is being enforced at some level in order to try to balance the competing needs of light for outdoor activities at night, but also preserving the night sky. And you'll notice that they're really wide ranging. There's a very high density of these policies throughout this part of the state, more than in other parts of the country. And again, a lot of that, historically speaking, has to do with trying to protect the observatories so that we can continue to do astronomy research in Southern Arizona. And we have some very high quality outdoor lighting policies here as well that we frequently point to as models that communities in other parts of the country and elsewhere in the world can use. So this is an important part of the overall strategy to trying to keep Southern Arizona dark at night as much as possible. To give you an example of a project that we were a little involved in, Tucson retrofitted its LED or its street lights from an older system to LED between 2016 and 2017. And in the process, the city decided it very definitely wanted to make sure that the result did not badly impact the observatories. And so as part of the transition, we substantially lowered the output of our street lighting system while maintaining illumination levels above internationally recommended minimum values that are considered to be safe. The total light reduction here in the course of the project was about 60%. And so we thought that one of the potential results of this is that we could reduce the brightness of the night sky a little bit over the city in the process. This just shows a view of one of our major city streets here in Tucson while the project was underway. The old sodium lights, that old kind of yellowish color that we were familiar with, was still installed. On the right side here, the new white LED lights are on the left. And there are some numbers here that are measured in this unit called a lux. That's how much light is on the pavement. I actually went out and measured this. These are my measurements. And this shows by how much we reduced the brightness of the lights. It was a factor of about 3.5 times going from the old lights to the new lights. But as you can see from the view, the illumination level appears very similar. And it was maintained in a sense that we weren't causing any problem. And in fact, we haven't seen any impact, as far as anybody can tell, to public safety as a result of reducing the brightness of the lights, which suggests that our old street lighting system was just simply too bright. And so one might ask whether it worked or not. And the short answer to that is yes. We did some research in 2017 where we compared measurements of the brightness of the night sky from locations in and around Tucson with some measurements that we made in 2014 before the project began. And we saw a reduction in the brightness of the night sky, especially as seen from the more distant observatory sites. And as an example, I have up here at top 2 views of the night sky from the Mount Lemmon Sky Center from before and after the streetlight conversion. And that little wedge of green up there in the corner, that's the light over Tucson, you'll notice shrinks in size between the 2 points in time. And that to us is an indication that the sky got a little bit darker. So we know that if you take these sort of lighting principles that we've articulated that we think are simple and easy and straightforward to apply, and you do it on a large scale, that you can get meaningful reductions in night sky brightness while maintaining the amount of light that you need at the surface down here in the city for people to go about their business at night. So it really was a win-win, save the city money, good for the community, good for preserving conditions of the observatories. And we really tout this as a major success story. So in the last 5 minutes I have, I'd just like to briefly go over some of the challenges that we anticipate in the next decade of lighting in Southern Arizona and some of the ideas that we have for how to deal with them. The legal marijuana trade has come to Arizona with the legalization of cannabis growing in possession in 2021. And we're already seeing some indications of large commercial greenhouses for growing cannabis. This is a big problem because cities don't regulate this right now. Counties don't regulate it in the rural areas. And they have the lights on 24 hours a day, pretty much, in order to make sure that the plants are growing at an adequate rate. We need a policy solution to this. We also need a technical solution to try to contain the light inside the greenhouses at night. We think this is another potential win-win where the industry can do its job and maintain high growth volumes for its plants, and we can keep that light inside their buildings at night so that it doesn't impact the night sky. But we're going to need to cooperate with the owners of those facilities and the lighting manufacturing companies to come up with good solutions. We're concerned about light associated with construction of the border barrier, which, despite the change in presidential administration, appears to still be going on in some places. This shows lighting along the barrier a bit east of the Nogales area. This is an image that was provided to us by the Wildlands Network. We don't know if these lights are active yet, but we do know that there is light appearing along the border associated with the barrier construction. These are two examples on the left along the international border in the Tohono O'odham Nation, and then on the right, again, east of Nogales in the San Bernardino National Wildlife Refuge. This compares March 2019 to March 2020, and you'll notice that there's lines of light showing up right along the border. This seems to be portable construction lighting. It's not the more permanent lighting as in the last image, but once the construction ceases, we're not sure how much light is going to be permanent. So this is something that we're keeping an eye on because this is bringing new light to places that are very naturally dark right now, where light is not present. And we think that that's a big problem, especially for wildlife that are trying to transit these areas. We're also concerned about the possibility of further resource exploitation, either on or near public lands throughout the West, not just in Arizona, but in other Western states. The series of images on the left shows oil and gas production wells coming and going near Chaco Culture National Historical Park in Northwest New Mexico, which is another one of our international dark sky parks. The result of that is shown in these series of images on the right. One at the top is a map of light on the horizon as seen from Chaco. The image on the bottom is an actual photograph of that light. And you can see that warm colored light in many places along the horizon, and that's coming from these installations where they're extracting oil, gas, or both. And we're trying to work with operators to come up with solutions for this. Again, the idea is not to stand in the way of the economic activity on and adjacent to the public lands, but to find a way to do it in a way that doesn't impact the night sky and the nighttime environment. So we're keeping close tabs on this. And lastly, there's this sense of managing both the growth in our region and the expectations that are associated with that. The graph on the left is the growth of population of the Tucson metro area over the last 50 years, which has been a more than 200% growth in that time. And it shows no signs of slowing down significantly. So more people are coming into the region, especially from areas where they might not necessarily prioritize dark skies. At the same time, this map on the right of the US shows by county how much light we are using per head of population. And you'll notice that Southern Arizona there is actually on the scale is fairly low. The cooler colors, blues, greens, yellows are where the light per capita consumption is a bit less. The challenge is how can we keep both of these things going on at the same time so that the city can grow and yet we're also continuing to use a bit less light than much of the rest of the country. So the takeaway message I hope you get taken from my talk is that the future of Southern Arizona's dark night skies really depends on the choices that we make today. And we hope that a combination of good conservation practices, effective public policies, engagement with the public through education and outreach, and this regional planning idea that we have is what we can do to make all of this possible, to grow the population and the economy sensibly and in line with demands on other resources, but to also keep our skies and our nighttime environment dark at night for the benefit of wildlife and astronomy and all of the other concerns that I talked about. And that we think that these solutions are simple and they're cost effective, and that if people just become aware of the problem and they see how easy it is to implement the solutions, that they'll make better choices and that we can keep Southern Arizona the astronomy capital of the world as it has been for decades. With that, I thank you for your attention, and I hope you enjoy the rest of our virtual Star Party.
And now for the Star Party portion of the program. I'd like to introduce the Tucson Amateur Astronomy Association. Thanks for the prepping and editing of this video with help from Jim Knoll, Bernie Stinger, Jim O'Connor, and Rick Paul. I hope you enjoy.
All right, welcome everyone. I'm Jim Knoll, Star Party Manager for the Tucson Amateur Astronomy Association, and welcome to our Star Party portion of the event. With me tonight will be on the telescopes will be astronomers Bernie Stinger, Rick Paul, and Jim O'Connor. So we're really happy to be able to participate in the Oracle State Park Virtual Star Party. So buckle your seatbelts and hang on, because we're going to have some fun observing our universe. So first thing we're going to do is take a quick look at where the planets are in our solar system, just so you can kind of see relationship of everybody. So let's go ahead and do that. So this is the current position of the planets. Let me zoom in to show you the center. And so you can see Mercury's closest to the sun, followed by Venus, and then Earth, and then Mars. Mercury and Venus are kind of on the other side of the sun from us right now. And then Mars is further up. Now, as we zoom out, in between Mars and Jupiter, this is called the asteroid belt. So there's just a belt of, you know, few asteroids left over from the formation of the solar system. And then as you move out even further, you've got the two gas giants, Jupiter and Saturn. And then even further out are Uranus and Neptune. And then way out here, the edge is Pluto. Now, Pluto used to be one of the main planets, but it was demoted basically to being a dwarf planet, and it's called a Kuiper Belt object because they think it's one of the nearest. You know, it's the very beginning of the Kuiper Belt, and beyond Pluto, there's probably a lot more objects out there that belong to the Kuiper Belt that we just have yet to discover. And we've seen quite a few of them out there, so we know that there's other stuff out there. And another thing, when you look at Pluto, you can see it's kind of got a different orbit from the rest of the planets. The planets around the sun are circular, whereas Pluto's got a little bit more of an ellipse. And then if you look at the planets on the edge, you can kind of see another difference. You'll see that all the main planets orbit in the same plane as the sun, and Pluto actually has a little bit of a different orbit. So that's another reason why they don't think Pluto, you know, is not classified as one of the main planets. So that's the current position of the planets. Let's take a look at what is currently in the night sky. All right, so this is the current night sky. You can see if you look off to the east, you've got the Virgo constellation coming up, Virgo the Maiden. And if you look kind of towards the southwest, you can see Canis Major's pretty prominent with Sirius. And then off towards the north, you can see Ursa Major, which is a Big Dipper. We'll look at some objects in the Big Dipper probably. But you can see the Big Dipper right here. And then if you look off of these two stars at the end of the bowl of the Big Dipper, they will normally point to Polaris, which is right out here. And Polaris is in the handle of the Little Dipper. And you can see the handle of the Little Dipper here, and then the bucket. A lot of people, if you're looking at Ursa Minor or the Little Dipper, you can usually see Polaris and you can see these two end stars. It's a little bit harder unless you've got good skies to be able to see the stars in between. So that's where things are currently in the night sky. So let's start some observing. We'll switch between 3 different telescopes and look at different objects in the night sky. Now, throughout the observations, when we're looking through the telescopes, you may hear the astronomers talking about Messier numbers or M numbers. Charles Messier lived back, and he was a comet hunter in the 1700s. And he was looking for comets, but he kept coming across these fuzzy spots. And these fuzzy spots, didn't seem to move like comets should. So he wanted to record them so that he wouldn't confuse them with comets. Well, as it turns out, his list of 110 objects are some of the best objects for amateurs to look at. So you'll see us looking at a lot of Messier objects or M numbers as we go through the list. The other main one that we look at is objects cataloged under the New General Catalog or NGC. So those are kind of the 2 catalog references that we talk about. So with that in mind, let's have some fun looking at some astronomy objects.
If I had a right way for all of the wrong ways I choose, I would know the difference, win it or lose. And freedom, it's only the word that you lose. Days become longer, the nights become stronger, and I feel for the way it happens. Turn of the season blue.
So here we are, set up just outside of the famous Canale Ranch House at Oracle State Park. And the first object that I'm going to show on the scope tonight is the Flame Nebula. The Flame Nebula is an emission nebula in Orion. And it's not only an emission nebula, it's also has elements of dark nebula embedded into it. It's about 1,200 light years away, and it's near the star Alnitek. That bright star you see just above the center is Alnitek. That's this star right here. That's the furthest most left star in the belt of Orion. So the Flame Nebula is right next to that star, but of course you need a telescope to be able to see that. Now, the reason the Flame Nebula is there, that's a huge cloud of hydrogen gas that's sitting there out in space, and normally you wouldn't see that cloud of gas because it would just be a dark cloud of gas. However, because Alnitek is a bright star emitting not only visible but ultraviolet light, that ultraviolet is hitting the molecules in that hydrogen cloud and causing them to emit light. And of course, it emits light in the frequency of around 6,500 angstrom units, which is indicative of hydrogen gas. And that's why we know it's hydrogen. Now, the dark streaks are actually foreground gas that is not being ionized. So this big cloud here would actually be much larger and more visible if it had not been for these dark streaks blocking some of the light from reaching us. In the center of this nebula are new stars that are fairly new in that they're probably billions of years. Most stars are in billions of years, so millions of years old. And by the way, this nebula was discovered by William Herschel in 1786. Now, in the same field of view, but off to the left, is another very famous nebula, and it's called the Horsehead Nebula. Now, this is a dark nebula. It's a dark nebula. In other words, it's gas that's not being ionized, and normally you would not see it. However, the gas behind the nebula, or the Horsehead, is being ionized and glowing red. So you can see that dark shape of the horse's head against that ionizing red hydrogen gas in the background. So this is the famous Horsehead Nebula. You see it a lot in astronomical books. It's about 1,375 light years away. And it was discovered not visually, but on photographic plates taken at the Harvard College in Massachusetts in 1888. The reason it wasn't discovered visually is that this is a very difficult object to see visually. Most people have a very, very hard time spotting this in a telescope. Most people have not seen it visually in a telescope, including yours truly. I've looked for it and have never been able to spot it visually. Only through the use of a camera have I been able to resolve this particular nebula. So this is the famous Horsehead Nebula in Orion.
So everybody, what you're looking at here on my screen right now, this is known as the Great Orion Nebula. It also has the numerical designation of M42 for Messier Object 42. It's one of the brightest nebulas in the sky, and it's the closest star-forming region to Earth. This nebula is heavily studied because it is so close to us. It's very easy for astronomers to study it. It's only about 1,400 light years away, which isn't that far in schemes of things. And what you're looking at there, the main structure of Orion, is about 34 light years across. So it's a big nebula. What you're seeing in the bright core there, the reason that bright core area is blown out is that's a heavy area of a star formation, and there's lots of little stars in there that are new young stars that are very bright, blowing that area out. Now, the other neat thing about Orion is this is an object that almost anybody can see. It's big, it's bright. It's located in the Orion Nebula, or in the Orion constellation. If you're familiar with the Orion constellation, he's got his belt going across. Then below his belt is the dimmer stars of his sword. So if you were to train a pair of binoculars up towards the sword, you would spot this little smudge of the Orion Nebula there. So it's something you can see yourselves.
This object is called Caroline's Rose. It's an open cluster, and it's in the constellation Cassiopeia. So we're lucky to get it right now because it's down near the horizon in the northwest. This constellation is an open cluster, which means the stars you see before you were all formed about the same time out of a massive gas cloud, about meaning on galactic scales. It may have taken a million and a half years for all those stars to form, but eventually the energy of them forming blows all the gas that's remaining kind of away, and they're sitting there. And usually they'll drift apart eventually. Sometimes they won't. If there's enough of them close together, their own gravity will hold them together for a long time. This was discovered by Caroline Herschel in 1783. Caroline Herschel was the sister of William Herschel, who was in history known as great astronomer, when in fact he was an orchestra conductor, and he only built telescopes to try to see how their behavior matched musical chord behaviors. Well, his sister Caroline was home, having been scarred when she was really young, smallpox, and her parents didn't want her to leave the house, but he wanted her to come over to England, where he was the conductor of the orchestra, and back at England to be a singer. But she was also looking over his shoulder while he did his astronomical work and correcting his work. And eventually he sent her to Oxford, where she got a PhD in mathematics, all the mathematics that was available to learn. And for the next 70 plus years, she was one of the best mathematicians in the world, but she was also a great astronomer. This she found in 1783, 2 years after her brother William had discovered the planet Uranus. And this is called Caroline's Rose. I'm showing a few more stars than that thing has because I'm integrating the image a bit. She saw it in a moderately sized telescope, about 8-inch telescope she was looking at. So I've got a 10-inch telescope and I'm imaging for 2 seconds right there. She called it the rose because it looked like rose petals at the center of a rosebud. And she got credit for it, for discovering it. And she eventually had over 1,000 open clusters to her name. So what I'm going to do is show what happened. They thought there was about 150 stars in that object. What I'm going to do is move it about 2 more seconds. And the picture will go off for a bit. And now I'm going to add 2 seconds to it. So we're up about 4 seconds. And let's see what happens with the image. And there you can see a little better picture. Those are like a star-shaped rose petals. There were actually 1,500, close to 1,500 stars in that cluster. You might be able to see some in the background starting to pop out. It's a huge cluster, and that's why it hasn't separated. It's about 7,500 light years away. It's about 1.75 billion years old. Its diameter is about 35 light years. And if I actually had a way to shrink my screen a little bit, or shrink the image in the screen, I'm only seeing the inner half of that cluster. So that's a fantastic find that she made, but she made a whole lot of them. So open clusters are good targets. They're easy to find in small telescopes.
So here's our next object for this evening. And this is actually 3 objects in the constellation Leo, and it's called the Leo triplet. The Leo triplet is 3 galaxies that are in the same field of view and roughly the same distance from Earth. They're 35 million light years away. So a truly enormous distance in comparison to some of the nebulosity and nebulas that we've looked at previously. They're composed, or the 3 objects are M65, M66, and this one down here, which is NGC 3628. Now, as you probably are aware, the M numbers represent Messier objects. Messier was the scientist or astronomer back in the late 1700s that looked for comets and spotted these objects. So most of them date back to discoveries in the late 1700s. In fact, these 2 on the right were discovered in 1780 by Messier. Now, why didn't he see this one on the left? It's pretty obvious it's a lot dimmer. And that's the reason why. His little telescope could not see them. They weren't bright enough for him to discern as being an object in the sky. But if we zoom in, we can tell what they are. Messier only saw blobs of light, but to us, they are very obvious. And for instance, and by the way, that little streak coming through here is a satellite that passed through my image while I was taking it just a couple minutes or just a minute ago. So M65, you can see, is a really nice spiral galaxy. It has really nice spiraling arms from the central core. And I think this is actually a barred spiral. It has kind of a bar shape across the central core with the spiraling arms coming off of it. If we look at M66, that's also a spiral galaxy. This one's tilted slightly. It's not edge on. It's maybe at about 70 degrees or so. So we're looking at one face of it, but you can see the spiraling arms spinning around the central core. Now keep in mind, these are billions of stars that are causing this light. And down below is the other galaxy, NGC 3628. NGC stands for the New Galactic Catalog, or New Galaxy Catalog, or General Catalog. Various people see it different ways. The nice thing about this particular galaxy is it has a beautiful central bulge and a dust lane that cuts right down the center of it, causing the upper and lower bulge to stand out. And on a really good night, tonight's not quite as good a night as I'd like it to be, but on a really good night, the very edges of it, and you can just barely make it out, the very edges of it on the top and the bottom kind of flare out. And for that reason, it's been given the name of the hamburger galaxy, meaning a piece of meat with a couple of buns and the lettuce flaring out on each side. So kind of a cute name for this particular galaxy. And as I mentioned earlier, these are about 35 million light years away.
So the object we're looking at right now is actually classified as two objects. It is a star cluster known as the Christmas tree cluster. If you see that, that bright star right in the middle, consider that to be the star on the top of the tree, and then the tree comes down. That's the Christmas tree cluster in there. But then it's also part of this larger nebula here known as the Cone Nebula. So the reddish part you're looking at here around the star cluster is the Cone Nebula. You can see the cone itself gets its name from this dark shape down here on the left that's shaped like a cone. But all this reddishness you see all through here on this frame is part of the Cone Nebula. This is a very active star forming region. And this object is huge. This nebula is almost filling my entire frame. To put that in comparison, I could fit a full moon onto my sensor very easily, and it wouldn't take up all that room. So this is a very, very large object. It's about 1,000 light years away. So again, it's relatively close to us. It's one reason why it appears so large in our sky. And it's about 17.6 light years across. Just as Jim was just mentioning about the Herschel family, William Herschel and his sister also discovered these objects. They discovered the cluster first. It took a larger telescope to be able to see any of that nebulosity there. But they discovered that in 1785.
Okay, this object, another open cluster, except this one is in Orion. It is Messier object number 35, which just means it's the 35th item Messier found in his hunt for comets, and he doesn't want us to look at this and be confused with a comet. So M35 has got a lot of features in Orion. It's scattered over a part of the sky that's almost the size of a full moon. So what you're seeing there is less than half of the open cluster. It's 3,870 light years away. At magnitude 5.1, its mass in the core where you're looking at is equivalent to about 1,600 suns. Across its size, its diameter, it's about 20 light years. And it's estimated to be relatively young compared to the last cluster I showed. This one's only 175 million years old. And it's got a name. It's called the shoe buckle cluster. And I've seen this full size and I had no idea why it got that name. But if anybody ever asks you, you can tell them, yeah, you saw the shoe buckle cluster. Again, this is Messier item 35, and it is in the constellation Orion.
Our next objects tonight, actually we have two in the same field again, is M46 and M47. M46 is this object towards the top. It's called an open cluster. And the one down below is M47. That's also an open cluster. And these are near each other in the same area of the sky, but they are not physically near each other. One is a lot further away than the other. So let's talk about M47 to begin with. This is M47 down on the bottom. I'm going to zoom in on it. There we go. Let's get a little bit of idea of M47. Again, this is an open cluster. And this one is about 1,600 light years distant. So it's well within the Milky Way. In fact, it's not really all that far away from us as far as objects in the Milky Way is concerned. There's about 500 members or stars within this open cluster. Most of these stars are very, very bright, what's called class B stars. They're very large, very bright, and are tend to be kind of a bluish white in appearance. Also within this cluster are red giants. Now I'm going to see if I can pick out a red giant for you. The red is a little hard to see when you do exposures because it will tend to overexpose. But I think this middle one right here, that one right where my mouse is a red giant. It has a reddish hue to it. This one here also looks like it might be what?
One up there about 2 o'clock, a little further out.
I'm not sure where you're talking, Mike. Point to it. Oh, way up there? Oh, okay. Well, yeah, all right. That's probably another red giant. I hadn't thought of one being that far away from the center, but you're probably right. So these are, again, a mixture of class B or type B stars and red giant stars. And most of these stars are in the 78 million year old time frame. Now, if we go to the other open cluster, M46, M46, you'll notice is a much larger grouping of stars. This one has close to 500 stars involved with it. But it's 5,000 light years away. So even though this one looks more numerous, it's much more distant. Probably 3-4 times further away than M47 was. Most of these stars are in the 250 million year old range. And there's an interesting object in the same field as this open cluster, and that's this little object right here. This is called a planetary nebula. It goes by the name of NGC 2438. This is a star, and you can see the star right in the center. This is a star that exploded and threw off its outer atmosphere, and that outer atmosphere is expanding out into space as a big bubble, and slowly getting larger and larger and larger. It happened about 1,400 years ago. I'm sorry, 4,000 years ago. However, this planetary nebula is not part of the open cluster. This planetary nebula is only 1,400 light years away. So it's much, much closer than the stars in the background comprising the open cluster.
What you see in front of you is another open cluster. I'm picking these open clusters because they're all setting real soon. In fact, this one's only about 7 degrees above the horizon, but it looks rather interesting. And it's one of the few things I've been told at schools that people can actually see what its name is. This is called the owl. This has got a new general catalog number, NGC 457. And this object, the owl, was discovered by William Herschel in 1787. It's about 8,000 light years away with an estimated age of about 21 million years. So it's pretty young. It's got several other names. It's also called E.T., if you've seen that movie, if you're one of the 20 people alive who've seen that, or it's called Johnny Five at times because of the movie Short Circuit, the little robot in it. And it's also been called the Katrina doll in some cultures. And the other name that I've heard it called in some planetarium programs is the dragonfly. So this one's got a lot of names. Oh, and by the way, in some Air Force bases that I've done star parties on, they say it looks like an F-15. Okay, that's their imagination. What I'm going to do is I'm going to make the object rebuild. In case you're having trouble seeing what it is, the eyes are up in the sort of upper right, and its feet is down towards the bottom left. But what I'm going to do is just do one little change. And what I'm going to do is right now that 0.96 means it's probably imaging at about 1.5 seconds. I'm going to change that to 2 seconds. And so just my doing that will make the system shut off and rebuild it. You can see his eyes are there. That's his eyes. And gradually his wings will fill in. You might be able to see his body start to come in from the upper right to lower left, and his wings are across his body. So by me changing what the imager was doing and making it go all the way up to 2 seconds and let it work on building what it was seeing on the telescope, that makes it easier sometimes to find the object. So there we have the owl. Now, the interesting thing about the owl is those eyes are fascinating. That's what makes it look like an owl. Except the eyes are only 4,000 light years away compared to the 8,000 light years of the rest of the cluster. It's an estimated 150 stars or so in that cluster, and it's 30 light years diagonally across, 30 light years in diameter if you drew a circle around that. So you can tell by being 8,000 light years away, these are extremely big, bright stars. They're 21 million years old. Many of them won't make it to 100 million. They'll be going supernova. And it's just a nice, friendly little object that looks like what you call it.
So the object we're looking at here is another nebula, another cloud of gas. This one's called the Flaming Star Nebula. And you can kind of see why. There's this very bright star here in the center, which is actually providing the illumination of all of that red gas you can faintly see in this image. The star is known as AE Auriga. It's got an interesting story. This nebula is located above Orion, and this star had a close encounter with another star in Orion's belt about 2.7 million years ago. And that close encounter caused it to be ejected from the area of the Orion Nebula complex, and it threw it out of the way. So now we see it above Orion, where the constellation is. Again, you're looking at an active star-forming region. All these gases are helping to form new stars. The reason it looks red, by the way, is that is from hydrogen gas. It's called the hydrogen alpha emission line, and our sensors see that as red shifted light when we bring it into our telescopes. This object is again relatively close, about the same as the Orion Nebula. It's 1,400 light years away, about the same. A little bit smaller. It's about 12 and a half light years across, depending on how you measure it.
The next object we're going to look at is what is commonly called M104. It's a galaxy in the constellation Virgo. And M104, which you can see here in the center, is an edge-on galaxy. So we're looking at it almost exactly edge-on. And this particular galaxy is also known by the common name of the Sombrero Galaxy because of its shape, which is kind of in the shape of a sombrero hat. And the galaxy has a very bright central core, as well as a dust lane that cuts right through it from left to right. And that dust lane is on the outer edge of the disk of the galaxy. So when you look at the galaxy from the edge on, you have to look through this layer of dust and dark material on the outer edge of it, and that's why it appears the way it does. Some may recognize the Sombrero Galaxy from the old TV show, The Outer Limits. It was a picture at the very end of the program, The Outer Limits. The Sombrero Galaxy is about 30 million light years distant. It was discovered in 1781. Now that indicates that it was discovered by either Messier or one of the astronomers, Messier's age, that had smaller telescopes and spotted these very faint, what they called nebula, because they didn't know they were galaxies. To them, they were just big fuzzy patches in the sky. So they called them nebula. And Messier put it on his list as number 104. It's about 50,000 light years wide. So it's about half the size, or maybe 1/3 of the size of the Milky Way galaxy, our galaxy. And right at the center, although you can't obviously see it, is a supermassive black hole. They know that because of the radio emission and X-ray emission that come from off of the galaxy as well. So this is the Sombrero Galaxy in the constellation Virgo.
This time, I've also gone for another cluster, but I went for it because it's another one of Caroline Herschel's finds. This is New General Catalog 2360, also known as Caroline's cluster. It's an open cluster in the constellation Canis Major, so we're about to lose that for the season as it goes away. It was discovered, I actually have the date of that, 26th of February in 1783 by Caroline Herschel, who described it as a beautiful cluster of pretty compressed stars. This, near 1/2 degree in diameter. Now that's about the size of a full moon, but that's not how it's logged. It's logged as about half of that size. So there were field stars that are no longer counted as being in that cluster. Her notes were overlooked until her brother, William, included them in his 1986 catalog 3 years later of 1,000 clusters and nebula, and acknowledged her as the discoverer. The age of the cluster, about 2.2 billion years old. So, you know, there's got to be a lot of population in that cluster to hold, for the gravity to hold it together. And because of how a star's life goes with its mass, and large stars only have a few to 150 or 200 million years to live, this one at 2.2 billion years is probably all within about 8 times the size of the sun. So these are average sized stars in there. The rest of them have gone away or have turned into planetary nebulas, supernovas, or white dwarfs. The thing that happens with the supernova on the young stars, it blows all the rest of the gas away, so no new stars can form. It's got a diameter of about 15 light years across, and it's located 3,700 light years from Earth. So that is an interesting cluster just because of its age. At 2.2 billion years of age, that's pretty old for a cluster.
So this magnificent object you're looking at is huge. It's filling my frame. It's actually going off my frame a little bit. It is called the Rosette Nebula because it looks like a pretty rose up in the sky. And it also has a little star cluster in the middle of it too. You can see there. This is located up in the constellation Monoceros. This is just absolutely one of the most beautiful nebulas in our sky, and it's heavily photographed. It's nearly as bright as Orion, except the light is all shifted into the red spectrum, which our eyes don't see very well with optical telescopes. So it's very hard to see this object with optical telescopes. It takes photography really to pull any of it out. And this is a little bit further away than the other things we're looking at, which also shows you how massive this is. It's 5,500 light years away, and it's 128 light years across. So to compare that back to the Orion Nebula, which we started out with, that's only 34 light years across versus this 128 light years across. So this is a very, very massive object out in space.
The next object we're going to look at is something quite different than what you've been seeing in previous images. It's not a cluster, it's not a nebula, it's not a galaxy. This is called a quasar. And it goes by the name of 3C273. I know that's not an exciting name, but that's what it goes by. And this is a quasar in the constellation Virgo. Now, what is a quasar? Well, the name quasar comes from a combination of words. Those words are quasi-stellar object, or quasar in short. Back in 1959, they detected radio emissions from the general area that we're pointed in right now. And those radio emissions were very strong, and they were trying to figure out, what are these radio waves coming from? And they were finally able to zero in on the fact that these radio waves were coming from a point of light that looked like a star. However, when they pointed telescopes at that star and tried to do a spectrographic image of it to see what it looked like on a spectrograph, in other words, out of light, to look at the different possible emission lines and see what materials it might be made out of. The spectrum was a confusing jumble of meaningless information. They couldn't figure out what it was. It didn't look like any normal star at all, and it had them really confused. And yet there it was. So it took a few more years, but in the 1960s, they finally figured out that it wasn't just a star. In fact, it was far more distant than any star. Instead of thousands of light years or even millions of light years, it was billions of light years away. And it was finally determined to be 2.5 billion light years distant, which is beyond any known galaxy at the time. And this is the object right here. This, what looks like a star, is a quasar at a distance of 2.5 billion light years away. And as you can see, be easily fooled into thinking that was just a star in our Milky Way. But it isn't. It's an enormous distance. In fact, that's almost 1/5 the distance across the known universe. So what is a quasar? Well, they finally figured it out. Took quite a bit of work, but they finally decided or determined that a quasar is actually an active galactic nucleus. It's a black hole that has an enormous amount of material that's falling into it. In fact, it's a supermassive black hole. And that black hole is so enormous that it's sucking up the stars at an incredible rate that are within the galaxy that it's in. And because of that, it's throwing out an enormous amount of light. In fact, the amount of light that it's throwing out, the amount of energy coming off of this infalling matter going into this black hole is so huge that it's been estimated as being as bright as 4 trillion times brighter than our sun. That's how bright it is and how enormous it is. The black hole, by the way, has been estimated as being 900 million solar masses. So it's sucked up a lot of material already. It's absolutely enormous, supermassive black hole. And that's why, even though it's so distant, it can be seen at such tremendous distance.
Hey, the object in front of you is an open cluster that lives in Orion. And surprisingly, it's called the 37 cluster because it looks like the number 37. And it's also called NGC 2169. It's an open cluster, as you can tell, looking at it. Discovery credit is given to William Herschel in October of 1784, even though 130 years earlier, the logs of a 1650 era astronomer mentions this object, but doesn't really say what its coordinates were. So Herschel gets credit for it. It's about 3,600 light years away from Earth, and it's only got about 30 stars associated with it. And it's only 7 light years across compared to some of these big objects. But I just like to show that because just like the owl cluster, you can tell that if it's called the 37 cluster, that's probably what it is.
So what you're looking at here is not one object, but many objects. This is known as Markarian's chain. It's a chain of galaxies over in the Virgo cluster, which is over in our eastern sky right now. I've switched over. I was showing you things in the western sky before. We've now shifted over to the eastern sky. But every smudge or bright object you see here is a galaxy, and it's almost a Where's Waldo. You can keep looking in this image and finding more and more galaxies. There's one here, there's one here, bright one there, bright one there, another one down here, another one down there, one over there, little one there. Go down over here in the corner. There's one there, there's one there. Start moving up on the right side. There's one there. There's one way up here in the right corner. And this area in general is known as the Virgo cluster of galaxies. There are just visible from our telescopes in this area about 50 galaxies. So if I pan my camera to the left, I'll get a whole, like 10 more galaxies. If I go up, I'll get 10 more. To the right, down. They're just all over this region. Now, we're also looking at things here that are much more distant than what we've been talking about before. These aren't thousands of light years away. These are millions of light years away. These objects you're looking at are on the order of about 50 million light years away. So the light you're seeing started 50 million years ago to reach the Earth. I think that's always pretty awe-inspiring to think about things in those terms.
All right, so we hope you enjoyed our star party under some dark Arizona skies. The last 3 pictures here were taken by Mike Weasner at Oracle State Park of the Big Dipper with Arcturus here, and then finally the constellations Gemini and Auriga. So we will see you at the next event.
So thank you to the Tucson Amateur Astronomy Association volunteers. Thank you, John Barentine, Dave Tominga, Mike Weasner. I'm Jennifer Rinio, Oracle State Park Ranger. Thank you to viewers who supported our virtual star party and dark sky celebration. We hope to see you at the park.